welcome to an episode on trigonometry. Today is an introduction to trigonometry, how it works, and also how to calculate the length of a side in a triangle. So here we go. So first thing, this is trigonometry and finding sides. Now this corresponds to 3e and 3f in your exercise books, so in your textbooks. So first thing, I'll start off with a situation, right? If I picture I've got this tree, let's draw in a tree. We're good at drawing trees, but a bit of a classic pine tree there. It looks a bit crooked there, but that's all right. And you want to measure its height, right? So that's your aim. How could you measure its height? Well, you could sort of, walk up to it and then climb up it, drop a tape measure down and measure its height that way. You could go up to the base, get one of those tape measures and sort of try to run it up the tree, but we know those tape measures sort of can flop over. And climbing up a tree can be dangerous. Well, there is a way using maths to measure a tree with you being comfortably over here, away from the tree. So, this is the safer way of doing it, and it's called using trigonometry. Pardon the pun, I guess you could say it's trigonometry. No? Okay. So, first thing is trigonometry is to do with triangles. Okay, so when you think of that word, trigonometry, we're thinking of triangles. So how can we make a triangle out of the situation? Well, this is you here, right? We can construct a triangle by drawing a line from you up to the top of that tree. The next thing is that we're going to assume that this tree is upright. So therefore, this angle is going to be a right angle. The next thing is we need to estimate the angle from the ground up to the tree. Now let's say you've calculated it as 20 degrees from your horizontal. The next thing is we need one more dimension. Now, what would be the least risky length to get? Would you want to get this length here? So you somehow go from here to the top of the tree, the height of the tree. Well, that's what we want to work out. Maybe we can just simply pace across with one of those rolling measuring tapes, go from here to the base of the tree. Now, let's say we measured that and the base of the tree is 25 meters, okay, from you to the base of the tree. Now, we actually have enough information to work out the height of this tree. And this is how it works. This is a bit of an introduction to it. We learn this process a bit later on. So, first thing is that we label our triangle. So, here's my angle. This is called theta. It's a Greek letter for an angle, like an X. Now, we can see that this side over here is opposite this theta angle. So we call this O for opposite. This side here, this 25 meters, is adjacent to this angle. So we've got O and A. Now we select which trig function we use using SO, CA, TOA. Now we care about an A and an O. We can see that this function over here, TOA, cares about an A and an O. This one here concerns H, which is our hypotenuse. You may remember the hypotenuse from the Pythag video from last time. So we're going to use TOA. Now the equation where TOA comes from is here. Tan theta is equal to O over A, where theta is the angle, O is the length of the opposite side, and A is the adjacent side length. We sub into that. tan theta, the angle is 20 degrees. The opposite side is valued at h. The adjacent side is 25 meters. We know algebra to get h by itself, which is the height of the tree. We times both sides by 25. So now we have our formula. This formula here, 25 times tan 20, will actually get the height of our tree. The tan function you can see is on our calculator, much like on your scientific, and I'm using the Desmos one here. Close my bracket and we can see the answer popping up here, 9.099, so 9.10 meters to 2 decimal places. Therefore, the tree is 9.10 meters tall. Now, gents, trigonometry is basically this, dealing with right-angled triangles, so there, using sine, cosine, or tangent, and using angles and sides to find other sides. This is different from Pythagoras, because Pythagoras does not use angles at all. So this is, you could say, another form of measuring angles and side lengths in triangles. So let's kick off. We want to go through this process, but break it down a bit more. So what we're going to do is start off with our first step of using trigonometry. So this one is called the labeling of the triangle. What I'd like you to do, right, I'm going to scroll down here, is I want you to draw these in your books. Okay? And if you do have a ruler, you could probably draw them a little better than me. Now, we've got 3 right-angled triangles here. I'm going to write down the key things we need to know on how to label these. We have 3 letters, H, O, and A. H stands for the hypotenuse. O stands for the opposite. Oh, let me start that one again. And A stands for the adjacent. Now, we remember from the Pythagoras video that hypotenuse is the longest side, and it's always opposite the right angle. Now, the opposite and the adjacent sides are going to be new if you've never done trigonometry before, and it's always talking to the angle, okay, the angle theta. So what I want you to do now is add these symbols here. Now, I'm going to write up here this symbol again. Now, this is called theta, and what it does, it's the unknown for an angle. So it's a special letter that we use for the angle in a triangle. So you can think of it like an X, right? But it's for an angle. So you see the value theta a lot. What we're going to do now is we're going to label this triangle. The first thing is that we know that the hypotenuse is always opposite the right angle. So what I want you to do is to label the hypotenuse in each of these triangles. So here we go. H, H, H. Now we can remember this because it's always opposite the right angle. Okay? So that's not too bad. We've got our H's there. We've got to label now opposite and adjacent. Let's do opposite. Opposite is always done from the perspective of the theta. So it's opposite side to angle theta. Now I'm going to look at these in orange. So we've got this value here. We can see this is the opposite side of our angle theta. So this one here is going to be opposite, right? This side length. So this is the opposite side length. Over here, here's our theta. Opposite to that, just there, is our opposite side. Now on this one here, here's our theta. So this is our opposite side. So we've done H and O now. The last side that we need to label in our triangle is the adjacent side. Now I know you can just label these now, but I would like you to go through the theory still. Adjacent is a fancy word for next to. So if I'm adjacent to you, it means just I'm next to you. Now, I'm adjacent to, in this case, theta, right? So let's change this guy's head for a theta head, just so we remember. So we can see here that this guy here is adjacent to theta. Now that's the same for the side that we're looking up here. So I'm going to look at this in green. Here's our theta, just there. The adjacent side, therefore, is here. This is our theta here. This hypotenuse is used up already, so therefore the adjacent side must be here. And over here, this is our theta. So this here, this is next to our theta. That must be our adjacent. So what we've done now is we've labelled our triangle. This is a really vital skill in the first steps of doing trigonometry. If you can do this, that's great. It means you can now move on to the trig functions. So once you've copied all this down, if you need to, you can pause the video to copy it down. We're going to move on to the trig functions. So here we go. Oops. So these are the trigonometric functions. Now, if you don't like saying that, you could call it the functions of trigonometry. It's a bit of a workaround. Whoop, I said trigonometric again. Quite hard to say that one. There we go. So what we're going to do is we're going to list out our functions. First thing, I'd like you to write down this. So, ka, toa. Now, so, ka, toa represents the three trigonometric functions that we use a lot in Year 9 maths. So, sorry, the pardon. You've got S, C, and T. Now, these represent our trig functions. Now, if you look at your calculator, you may also find sine, cosine, and tangent. So what we're going to do is we're going to write this out as the equation that this mnemonic belongs to. So sine theta is equal to then O over H. Now, this mnemonic helps you find that equation. Let's see the connection. So that S comes from here. And what's that word? It's actually spelt sine. So you can think of it as sine, that word. That's how it's pronounced. Now, a typical thing is it's a sin to say sin. And some people still do it. So you want to say sine. Where does the O come from? Well, we can see that the O, I've got a red now, goes here to the top. And the H, that's here that goes to the bottom. Now, this pattern is repeated for each of these trig functions. If you can see that pattern, then you will always get this correctly. Now, there might be one thing you've noticed. Sine always needs our angle theta. So you always have to have the theta after each function. Now, we're going to go a bit faster. We're going to produce the rest of these, and keep in mind this pattern of how the equation is made. So let's go. C stands for cosine. We have to give cosine an angle, so we call that theta. You put the equals in, then I hope you can guess, what do we have as the ratio? A over H. So C belongs to cosine. Next, this is our angle theta. Then we've got the adjacent going here, and we have the hypotenuse going on the bottom. Do you see that pattern coming up again? The last one is tangent. So, tangent theta, I'll just move this down a little bit to give myself some space, is equal to O over A. So, we've got tangent there. We have our theta here, the angle. Then we've got our opposite side as a numerator, and we have the adjacent side as the denominator. So this pattern holds for all of them, right? So as you can see, these are our three trig functions. Now with these three trig functions, we can solve for the sides of any right-angled triangle that we'll see in the Year 9 course. So katoa helps us remember sine, cosine, and tangent equations and when to use them. So if you want to note there, this tells you when to use either the sine, the cosine, or the tan function. Okay? So these are very useful. So katoa. Let's move on. We're ready to solve now. We've got our labeling triangles and our trig functions ready to go. Let's solve some triangles. Okay. Now down here, I'm going to write out 3 triangles that I want us to solve. So here we go. I'd like you to copy these down in your books if you're following along at home. So here we have our 3 triangles, and what we're going to do is we are going to make a bit of a mnemonic for each one of these. Okay, so here we go. On this side, I'm going to write this. Number 1, so this is the rule, I'll just say the steps for trig. Label the triangle. Step 2 is we want to choose the trig function. Step 3 is we want to use the formula and solve. Step 4 is we want to do a sanity check and check units. Okay. Now with this in mind, I'll come back to this we'll go through each one of these steps and make sure we've done each one as we move along, okay? But this is sort of the process of how to do trig. Here we go. We've got our first one here. First step is we wanted to label the triangle. So let's label all three of these triangles. Here we go. First one. Well, what was our way that we labeled the triangles again? Well, you had three letters. You had H, O, and A. So let's label each one of these with the H, O, and A sides. Here we go. H. Well, this is the H here because it's opposite the right angle. Here's our right angle, so this side is the H, the hypotenuse, and the hypotenuse is this side here. Done. We've done all the H's. Let's do O's. Now, O's are the opposite sides. So, opposite to and remember, these are always done from the perspective of theta. So this is opposite theta here. In fact, let's label theta, just to remind us, actually. I'm going to write that in. Let's label theta as well. So we've got a theta here, that's the angle. This one's theta, it's 30 degrees, and this one's theta here, the 50 degrees. Now that's just good to practice that symbol. So we've done the thetas, let's move on to O. Here's our angle, across from this is the opposite side. Here we have theta, so across from this is the opposite side. We have theta here, so across from this is our opposite side. Okay, we've done opposite now. Let's move on to adjacent, which I'll do in orange. Okay, here we go. Angle must be this side here because this is the hypotenuse. So we've got adjacent here. Here's our angle. This is taken up by the hypotenuse, so therefore this side must be the adjacent. And over here, here's our angle. This side must be the adjacent here. So there we go. We've just done all of step one's things for labeled triangle. So let's tick them off now. The next thing is to choose the trig function. Okay. Now, what I'm going to do is consider what do we care about here. So this has a 10 here for the hypotenuse, and we want to find x, which is the adjacent. Do you see how we're not given anything about O at all? We don't want to solve for it, and nor have we given any information. So I'm going to go through and cross off all the things I just simply don't want to solve or use. So we don't want the opposite over here. What else is blank? Well, H is 14. Opposite has X, A, blank. There's nothing we want to solve, and we're not given on that side. Over here, the hypotenuse is blank. So let's cross it out. Let's write out the letters that are left. We have A and H. A and H. Now, we want to, as step 2 says, choose our trig function. Okay. Now, which one matches up with this? Now, in red in a box, I'm going to write this. So, ka, toa. Now, this is a thing that helps us choose our trig function. So which one uses an A and an H? We can see ka does. So I'm going to write that in. Ka. Over here, what do we care about? We've got O and H. So which one uses O and H? Let's have a look. So uses O and H. Over here, we've got an A and an O. Which one uses an A and an O? Well, you may notice it's not A and an O, it's O and an A. So let's rewrite it. O, A, and we know it must be toa. So we've chosen the correct trig functions for each of these. The next step is to use those formulas to solve for the unknowns. So let's see if we can remember those formulas. Can you remember what cosine was? Let's see if we can get the equation out. C stands for cosine, cos. Then we need to give it an angle theta. Then it's equal to adjacent over hypotenuse. Sine is, S is sine. We have to give it an angle theta. It's equal to O over H. The last one is tangent. Tan of an angle is equal to O over A. Now that we have all those equations out, we want to use this formula. So we've written out the formula, we've got to use it now. So here we go. Theta represents the angle. The angle in this case is 40 degrees. Adjacent corresponds to our letter X, and H corresponds to our number 10. Over here, we'll do this one. Our theta in this case is 30 degrees. Our opposite in this case is X. We can see that there. And our hypotenuse is 14. The last one is tangent. Tan, and our angle is 50 degrees. The opposite side we can see is X, and the adjacent side we can see is 7. What we have now is we've made all our equations. We want to solve for them now. Okay, so we've done the use the formula. We just want to solve for these now. Now these are all actually really nice. They use a bit of algebra, which we all know and love. We want to get x by itself. Now x is currently being divided by 10. So how do we get rid of a divide by 10? We do the opposite. We times by 10. I'm going to change that to orange because that's what I've been doing those comments in. Okay. That's equivalent to a divide by 10. Now the opposite is timesing by 10. What we do to one term, we do to the others. Now we know that cancels. We're left with x is equal to 10 times by cosine 40 degrees. Now we're going to go through all of them and do this. This is a divide by 14. Opposite of dividing by 14 is timesing by 14. Let's rewrite that equation. X is equal to 14 times by sine 30 degrees. The last one over here is divide by 7, the opposite of which is times by 7. Underneath, we've got 7 times by tan 50 degrees is equal to x. Next is we can use our calculator. Now I'm going to swap the left-hand side with our right-hand side and vice versa, okay? So here we go. 10 cosine 40. Oh, it probably helps if you're clear. 10 times by cosine 40, then close your bracket. Now outcomes for me, 7.660.4 ... Now, we want to round this to 2 decimal places. So, if I was to draw a line here at the second decimal place, consider, is the neighbour to the right, the 0, going to round up this 66? No. So it's not going to go to 67, it stays at 66. 7.66, and let's just double check our units. In this case, it was meters. So we know that x here is 7.66 meters. Does that value seem to make sense? Yes, because it's lower or shorter than the hypotenuse side, which is known as the longest side. So that's looking pretty good. There we have it, we've done our first side. Let's finish off the rest and practice using our calculator. So this one is x is equal to, and then we type in 14 times sine 30. 14 times by sine of 30. 7. That's a nice clean number. Now in this case here, I'm absolutely fine, even if it's to 2 decimal places. You could write 7.00, but you could just write 7 millimeters as well, as it's exact. Now, sine 30 is an interesting function. It's called an exact value, and it's 0.5, a very important value. The last one is 7 times tangent of 50. Close our bracket, and we get our answer of 8.3422 yada yada yada. So if we want to round this, put the line here at the second decimal place, Is the 34 going to get rounded up? No. So 8.34. Then we add our units. In this case, it's centimetres. So there we go. We've done our trig. And let's do our sanity checks. We've got our units in there. Does 7 millimeters make sense? Yeah, it seems pretty good. It's lower than the hypotenuse. And is a 8.34 centimeters sensible here? Yeah, it seems reasonable. It's quite close to 7 centimeters. And the 50 degrees means it's a little bit bigger than 7 centimeters. So yeah, that seems good. So I hope you found this video helpful. A bit of an overview is we started off with our tree problem. You can go back to that and see if you can do that again. We labelled our triangle using hypotenuse, opposite and adjacent. We learned about the Greek letter theta, which is used for the unknowns for angles. It's like an X, but for angles. And we learnt about how to use the trig functions using the mnemonic so, ka, toa. We learnt it's a sin to say sin because we say sine. We learnt how to get the equations from these so, ka, toa functions. We also learnt how to actually use the trig functions to help us solve for the unknown sides. You may notice we used all of the 3 trig functions, cosine in this case, sine in this case, and tan in this case. I hope this video was helpful and thanks for watching.